Okay, I think we'll go ahead and make a start for this presentation of MSD at Home. My name is Professor Donald Bates. I'm the Chair of Architectural Design at the Melbourne School of Design, the University of Melbourne. I begin proceedings by acknowledging the traditional custodians of the land on which I'm presenting, the lands of the Wurundjeri people of the Kulin Nations, and pay my respects to their elders, past, present, and those emerging, and to all Indigenous and Torres Strait Islanders who are witnessing this presentation. I'm really very, very pleased to be able to introduce and for MSD at Home to host Winka Dubbeldam. I consider Winka a good friend. We've had occasions to meet both here in Melbourne previously when she's visited Melbourne, and then I've been able to meet with her in New York, at Penn, at her school at the University of Pennsylvania, as well as other places around the world, whether that's Venice or LA or any place. Winka is the founder and partner of the New York firm Archi-Tectonics NYC, with offices in the US, the Netherlands, and in China. She's very widely known for her award-winning work, recognized as much for its design excellence as for its use of smart building systems, sustainable materials, and innovative structures. Archi-Tectonics recently won the Asia Games 2022 design competition in Hangzhou, China. This was won back in 2018, which includes a 16-acre park, 5 buildings, and 2 stadia that are under construction currently and will open in 2022. The Masterplan itself was recently won an award through the Plan Awards of 2020, and her 512 GW Townhouse was also an awardee in the 2020 Rethinking the Future Global Architecture and Design Awards of 2020. Winka Dubbeldam is also the chair and the Miller Professor of Architecture at the Weizmann School of Design and director of the Advanced Research and Innovations Lab at the University of Pennsylvania, where she has gathered an international network of innovative research and design professionals. She previously taught at the graduate architecture programs at Columbia, Cornell, Harvard, among other prestigious institutions, and she's currently an external examiner at the Bartlett UCL in London, and was recently named one of Design Intelligence's 30 most admired educators back in 2015. There are a number of publications. There are 3 monographs. There's Winka Dubbeldam Architect from 1996. There's AT Index from 2006, and Archi-Tectonics from 2010. And she's currently just in the process of completing a new publication called Strange Objects, which should be published sometime this year through Acre out of Spain. And that forms a bit of the basis of some of our conversation today. Again, as I said at the beginning, this is really a pleasure and an honor to have Winka join us. When we set up the MSD at Home series, she was one of the first people I thought about trying to get involved. So I thank her for accepting the invitation and very much look forward to her presentation today. So I'll turn it over to you, Winka. You can take it away and share the screen as you need.
Thank you so much. I mean, it's a great pleasure to be with all of you. Big fan of Australia, sadly. It's very hard to come and visit you guys right now, so we have to do it in this way. But thank you, Donald. This is really fun. I'm going to share the screen. Let's see whether it works. You should be seeing that right now. Okay. The work shown here explores the solid as object, deep and complex with character, expression, and identity. After 2 decades of digital design, we have reached a new platform, a new normal. While intuition and skill remain at the core of the design process, digital design and robotic production are the norm, and by extension, digital craft and integral design are the future. Technology, aesthetics, and performance merge into an integrated whole that expresses itself as surface solids and strange objects. Here, a solid not to be understood as solid, as a rock, but more as a complex reading of a varying 3D solid surface, thing shapes in progress of becoming, and massive things. These are the antidote to the singular, the planar, the transparent, and the flat. Jane Bennett advocates for the vitality of matter, giving agency to things, things that produce effects in human and other bodies, organic and inorganic bodies, natural cultural objects. All are affective. The generative character of things and objects is prefaced here and are what Husserl describes as phoronomic shapes, formations developed out of praxis and thought of in terms of gradual perfection, clearly serving only as the basis for new sorts of praxis, out of which similarly new constructions grow. So the idea here is that this is not about a formal investigation for the purpose of being form, but really to be generative. Let's see whether I can get this to move. There we go. So the praxis, as I just mentioned, is actually located in the bottom of Manhattan in the Seaport District, and we are most of us are housed across the river in Brooklyn and take the ferry in 4 minutes. So it's a very short commute. But we are finding ourselves in very strange times. And I think you share with us that we have warmer temperature that increase the risk of desertification. And they also cause greater risks of droughts, followed by resulting scarcity of water. The global land and ocean surface temperature for May 2020 tied with 2016 as the highest in 141 years. Temperature extremes will affect sectors such as agriculture, tourism, and energy production. Cities can face new challenges for supply water and other basic resources. As of 2019, more than 141 million Americans live in places with unhealthy levels of air pollution, according to the American Lung Association in 2019 State of the Air report. Other harmful types of pollutions are, of course, ground level ozone. This is what we call the Anthropocene. The Anthropocene caused by us. And of course, as we all know, and I know you're just entering level 3 or 4 for COVID, what was really a very strange situation that in the northeastern of the US, we actually had a 30% reduction in pollution in March. Sadly, all scientists are warning that this is not an ongoing trend. And as we know from China, that it's very quickly back to normal. What I would like to show is very quickly some effects and research we've done in different buildings in order to get to the last 2 projects that are the ones I want to talk about. The first one is surface intelligence, smart skins that have passive solar energy, are energy saving, are usually prefabricated and use renewable sources. The first building I discuss is 497 Greenwich Street. It's on the west side of Manhattan. This was actually quite an amazing thing to have your building show up in Google. Obviously my first building. But what was really interesting here was that the research was focused on the wrapping of a existing 6-story warehouse. And the notion was to decode the building code in the sense that we took the inclined plane of the building code and used mathematical tool of intersection to inflect the surfaces on top of each other, causing a wave of glass rather than 2 different systems. So inflection caused volume and created a facade that was a connective membrane rather than a divisive wall. Here you see that we also took the chance of taking the folded glass that is actually double glazed and folded to also separate the horizontal and vertical mullions to create bands of glass rather than a grid of glass. And curved annealed monolithic glass is something that is made in gigantic ovens. Our producer was in Spain. You could say that this is one of the first kind of parametric facades that is completely designed 3D and then communicated through all the manufacturers in a very fast, efficient way to kind of make sure that 3D models are used rather than 2D drawings. So the interest here is in an architecture conceived or invented from the smallest bit or atom of information, a seed, rather than a formal design methodology. Invention, as the originator or the seed of the architectural object, occurs in the middle, not at the start of the design process and not as the final outcome. It is rather in the prototyping phase, like you see here, that serves as a discovery process, instigating the growing of a design rather than the composition or the master plan. Search for universal beauty is not the goal. Rather, achieving character identity and the optimized is the preferred outcome. Here you see also for us it was really important that the glass was volumized as to the major degree at the ends of the curtain wall. So here was the top of the curtain wall, here is the bottom, the street facade, constant varying mullions, and the glass is merely here suspended on points. Really important was that it has passive solar energy, natural ventilation, and that the building actually uses a minimal amount of energy, but is really warm, is warm in the winter, and in the summer there's a smart solar film in the glass that stops the overheating. The crease, as you can see, between the two is mediated by small prefab concrete balconies that creates a division but also connection. The second building I want to show is a building we did very close to the other one. It's both in the south and the southwest of Manhattan, you could say. It's close to Soho. This is Tribeca. Here the idea was really to look at a landmark in a completely different way, not to copy old buildings, but to look at optimization of the traditional construction, material ecologies, and proportional systems. The building is completely floating from its core and is poured in place concrete. Hence, it allows for really deep cantilevers and double height spaces, optimizing the south garden facade that you see here, with 12 feet balconies or sunrooms, allowing for shade in the bedrooms, but a huge amount of light in the living spaces. It's a completely non-standard building in the sense that there is just 7 villas in the whole building, with the front facade being a pixelation of, I'll show here, a pixelation of stone, translucent stone, glass, and translucent glass. So actually really negotiating the rhythm of the two neighbors, allowing for proportional jumps, but seeing the building as a three-dimensional grid of pixels that you see here. So the pixels are really kind of cantilevered aluminum boxes with the translucent stone in it. Again, it has openable glazing. And again, the prototyping was really important. So it was this actually the seed or the kernel here, you could say, was the idea of using translucent stone as a unfinished material on the outside. It was the first time, I think, a building actually used translucent stone on the outside. It's done a lot in alabaster inside walls, but not so much on the outside. So here you see the prototype in Italy. It was very lucky that the factory was actually in Florence. And then we found that the stone that we needed was in Portugal. So we had to go to this quarry. If you look at the size of these look like toys, but these are actually the biggest possible trucks. So you can imagine you're probably as high as one of the wheels. So these quarries are absolutely enormous, and the way you're trying to figure out the color of the stone is by choosing these gigantic blocks of 7 by 7 by 7 feet, and you're trying to figure out which one will be the right one. And then you get this really interesting pixelation that not only works on the outside as a glowing facade, but on the inside actually starts to pixelize the buildings across the street also. So there is a really great varying degree or optimization of private spaces, in the sense that the stone and the translucent stone and translucent glass really allow for a very soft boundary towards the other spaces. And of course, on the top of the building, it gets greener and greener as you go. We recently finished the townhouse that Don just mentioned. It's the 512 townhouse. It's an 8-story townhouse for one family. It's quite fun. And what we realized is, when we looked at the existing building of 4 stories, that our extension with all its setbacks for the city got to be almost as large. And we decided to introduce a 3rd building that is kind of an idealized building, climate trellis. Trellises are screens and escape all building restrictions, building code restrictions. So this trellis is a very spacious trellis and much larger than the building. We decided to keep the fire escape landings, as we said to the DOB, on the building. So there is, behind the trellis, there's a set of balconies where you can read, smoke, grow plants, whatever you want. But then the setbacks on the top start to have much bigger spaces. And the idea was really to create these exterior spaces as private spaces. And to allow this trellis to be openable, allowing for passive solar energy again in the winter, but in the summer to cool the building and have a huge amount of privacy. The prototyping phase was really fun. We had decided we wanted the trellis to operate like a bird wing. So to kind of optimize the fins almost like feathers. On the wing, so when the screens are closed, the panels are completely flat. But when you fold up these panels, they're kind of like fingers coming out of the facade, which I'll show here. This is us adding actuators to the facade to see whether certain parts could be actually automated and more smooth. In general, it operates really easy, but we thought in winter this would be easier for the client. And then here you see how it actually operates. So the townhouse is quite small in floor plate. So it means that essentially every floor has its own kind of small program. The ground floor is a kid's room. The second floor is the kitchen and the family room. Third room is dining or whatever. So you keep going. Every room has its own little program. But what was great is in this townhouse, because it is for one family, we were able to generate huge vertical cuts that are really connective in nature and allow for the facade to really be seen. In the back of the building, we cut a really long slot. There is an 8-story black stair and glass elevator that catch the south light. So although the building is enclosed on 3 sides, you have in the back of the building suddenly a huge amount of light, and there's also a skylight on top of this stair, and then you get the trellis that creates this green kind of screen. And then here you see the difference between open and closed as the building transforms when it's being opened. This is the lower floor. So the lower floors, we basically just restored the old building and created gigantic spaces with just brick and wood. But then on the top, oops, sorry. On the top you get, oh, this is giving me, oh, okay. Sorry guys, it's hiccuping. Let's see whether it wants to. So on the top, you can see it's much lighter. So when you go from a pretty dark brick building, you go up to this really small tower, this one family tower, which is completely transformable. Think shapes are things we are really interested in, and think shapes are solids that have a level of innovation, individuality, and character, and often allow for branding of the companies. I will show, we have done quite a few. I show the most recent one, that is a space for meditation. So it's a kind of a new meditation concept that also needed a proto space in Manhattan. The idea was to hide completely the inside of the space and to not reveal from the outside what really was the inside. So on the right you see the outside, on the left you see the inside. And then develop seating units and optimize the space to see how we could have as many people in this space with still feeling comfortable. We had a very precise client, so our office had to sit on the floor to actually practice how close was comfortable and how you could still do some sort of movement. You see our golden retriever was also interactive in this situation. And then we started looking at portals and how to work with this space that is kind of essentially a set of strange massive objects, or protobodies as we call them. Essentially, what was really important about the dome space inside is that the ellipsoids basically have to be tested on sort of an optimization. They're synclastic domes, elliptic paraboloids, and the density of the material and the spacing of the grid was really, really important for us to figure out exactly. A synclastic dome has identical curves, and both dimensions are curving obviously in the same direction. In this orientation, the dome is also under compression everywhere, which is really important for us to be able to make this self-supporting. Huge pressure was on the bottom frame holding the dome in place. The real scale mock-up was needed after extensive parametric modeling and computational strength testing. In collaboration with the ARIA group in California, who is essentially an expert in car design, advanced manufacturing, and rapid prototyping, the grid shell prototype was further detailed and the necessary fastening methods developed. Here you see essentially there was a no judgment seating policy. You can imagine a meditator is not necessarily a yogi, so there was a possibility to sit on the ring of the dome as a normal seat. There was another second version where you could sit against the seat but on the floor, or if you're more experienced, to sit on the individual units on the floor. The grid shell had an open oculus on the top and a low horizon of light on the bottom. It was at once the most simple and highly engineered space we have ever made. It's a huge contrast. So actually what for us was most important is if you came into the space, the lighting is all on. But then as the meditation starts, the lighting goes down to this low horizon that stays on as a soft glimmer to give you kind of a stable line to focus on if you have problems meditating for a longer time. The prototype was, as I said, with the ARIA group in Los Angeles. So there's actually a prototype made 1-to-1, which is not usual. But since they have a gigantic factory and robots, we decided to mill it in real scale. So it's quite beautiful if you see the inside of the outside here. Normally, as you see later, you don't actually see this shape, but this is only the inside shape here. And what was quite amazing that at the client's insistence, the whole team meditated in the factory's prototype, including the manufacturers. Quite the experience, you can imagine. The other thing that was quite important was it's a proto space in Manhattan to be rolled out worldwide. And the prefabrication was the only way to figure out how to make local manufacturing possible and not to have to ship too far. So as you all know, prefabrication is the way that you can really control construction costs, economize time, wages and materials, but it's also clean, it has no waste, and has a fast installation time, which for commercial spaces is really important. Here we tested with the prefab people quite a few more connection details to get the force of the dome. As I said, it's the paraboloid has a huge amount of force that it wants to push out as the bamboo rods are bent. So as you can see here, there's actually a very deep connection point for the rods. There is also in the benches kind of a highly precise air conditioning system that pushes air out behind the dome grid, the grid shell, and allows for lighting behind it. So the idea is really that this frame, that is a prefabricated frame, holds all the technology that has to do with cooling and lighting, whereas the dome itself, that has a huge canvas sail on it, hides micro speakers that were distributed evenly. And then, as you can see here, these are massive shapes. The idea was really that there is an option to make kind of a new beauty, or maybe almost approximate the ugly, by creating things that are slightly uncomfortable, out of scale, and are an effect that can be used as an opportune moment to create unusual effects, oppressive moments. In a project like Inscape, its massiveness is in relation to the space it occupies. The meditation dome appears immense as it is squashed into the limited boundaries of the ground floor space, and is vast in its expression, creating a sense of wonder and strange beauty, if not unease. It's not unlike how Edmund Burke describes the sublime. The sublime for him then is our strongest passion, and it's grounded in terror. I wouldn't say that this is terrifying, but it's still a strange unease. It is not exclusively an unpleasant emotion, for danger or pain in certain circumstances gives us delight. Inscape, with its rather unusual clumsy proportions, approximates this feeling of danger, but also of wonder, and often the visitor's curiosity wins. Once inside the dome, pure beauty takes over. The dome, with its intricate flower-like pattern, glows, and surround sound holds the visitors in a soft embrace. The proto-body is also extended to the retail system, where we made self-supporting shelves that, because of a triangular shape, lean against the wall and support themselves. And basically, a startup company, Inscape, we had no idea whether they needed retail or not. So the idea was to develop a system that of bamboo shelves that could be both a sound baffle or an art piece if not needed. But in the end, there was actually a huge amount of retail, and retail became one of the major sources of income, especially right now with COVID. As you can imagine, not many people want to sit and breathe in a space together. And then here you start to see how the dome is conceived as a grid shell, a radial structure that derives its strength from a double curvature and is constructed of a lattice. This free form and free span dome allows for a space to be free of any columns, and a minimal appearance was facilitated by thorough testing of strength and size of individual bamboo members. It was also really important for us to create kind of an entry that was more of a tunnel-like space. And then here you can see the kind of configuration from bench to free seating in the middle. And then we were quite honored that Wired magazine actually said we were one of the 25 masterpieces, which were really architectures in 2016. So we were probably the smallest project, but it was very nice that it was included. And then I'll move on to the Asian Games. So the Asian Games are actually 116 acre park. That was a spelling mistake I think we made, and not Donald's mistake, but it's 116 acre park and 7 buildings. Asian Games are like our Olympics. And we won this with an extensive team of very well-known developers and structural engineers. So we had a landscape architect called Melk. Engineers are Thornton Tomasetti, who are both in US and China. MIC is mobility and chain. It's a traffic and accessibility engineer. And Ryan Soames was our MEP engineer, as both the park and the buildings are to be designed sustainable. So the park is a sponge city concept in China. It's basically wetlands, porous pavement, and really important to kind of hold the existing river and recreate the wetlands. And the buildings are all sustainable, as I said. The site was absolutely beautiful. This is not often that you actually find a park where you're creating a park. So this was really quite a surprise. And as I said, the idea was a sponge city. Our concept for the Asian Games Park and stadiums emerged from a unique combination of innovative design methodologies and local cultural heritage. By utilizing vernacular artifacts as seeds for our pragmatic formal investigations, we created a poetic, multi-layer design with advanced construction technologies, nested within a beautiful park landscape. Really important for us was that the Asian Games are essentially a few weeks, and that we're creating a mile-long park with 7 buildings. So we focused very much on the Asian Games because you have rules and you need to follow them. But we also conceived the park as a green lung that had different groups of visitors at different times of the day with different requirements. So sports, cultural events, food, nature, of course, entertainment and connectivity were all equally important. We won this competition not because we followed the rules, but because we did not follow the rules. The competition had asked to put the 2 stadiums right along a road that divides the park in the middle. And we decided when we were studying that made the parks into kind of the backyard of the stadiums. And we proposed a completely different proposal that you see here, is to put the stadiums as generators and activators in the park sections, and then connect it with a kind of what we call a valley village, which is essentially an open air shopping mall that connects under the road, but also under the river. So here you see that a little bit bigger. You have the North Park, community and sports oriented mostly, and then the South Park, recreational and civic oriented. All the edges are very porous, so everyone can come in from every angle. And then there is a field hockey stadium, 5,000 seats, 14,000 square meters. The Valley Village, as you can see here, goes under this river and under the road. So it's a very Dutch proposal in a way. We make basically the river into an aqueduct. And then the lower stadium is a table tennis stadium, also 5,000 seats and 3,400 square meters. This is the whole proposal in one jump. So here you see the road, the Valley Village going under, pedestrian bridges going over, the wetland area, the stadium as it sits nested into the topologies, and the field hockey stadium over here. The wetlands were really important. They have a huge problem because they are solidifying all the surfaces with roads and pavement. And as we know, that stormwater at some point needs to go. So here we restored the original wetlands with local vegetation also, and tea houses that look out over them as people are also using the wetlands for sports. Of course, we had other things such as kids' playgrounds and other sports fields. So there's tennis, field hockey, basketball fields all throughout the park. But maybe the interesting thing was to kind of see this Valley Village that really connects the 2 stadiums. when we looked at sustainable building, you know, something that is underground is not necessarily sustainable. It needs a lot of air conditioning, artificial lighting. So we decided to make it an open space, but with green roofs and quite a bit of shading and solar screens. So these shading devices are also solar paneled. We had a zero earth strategy that basically meant that whatever we were excavating from making this valley to create topology in the park. So you get a quite voluptuous park that really cradles the buildings inside of it, and also we created natural ventilation and natural heating and cooling systems for all the different systems. Here you start to see how buildings really sit in the topology very nicely, the Valley Village from both sides, and then the stadium. And then here on the road, looking back at the field hockey stadium. I'll go into the buildings in a second, but here you see the green roofs. The idea was really the valley was a green valley. So nature really dips down with it and allows for natural shading and cooling. The stadium designs, the field hockey stadium was developed as 2 ellipses. Since the hybridity was so important for us, or the use after the games was so important for us, we decided to design everything as a landscape feature. So although the fields are Olympic size or Asian game size, the overall field was a recessed dip in the landscape that was an ellipse, the same size as the roof of the shading of the stadium was, which really is kind of a vesica Pisces, or a seed of life, as they call it. It's a very ancient system that was used by Euclid, by Da Vinci, and has been also used in many kind of more symbolic ways, such as the Freemasons. We thought this was interesting to kind of play around with these kind of double meanings and kind of ideas of seeds to kind of really indicate the double function of it. So the design was very simple. We designed a stadium that we really liked in solid concrete. As you can see, the field is really recessed. It's actually 5 meters high here. And then there's the space under the seating is really the direct consequence with a glass curved facade. That then gets covered by this 125 meter free span wing, a diaphanous wing of translucent fabric that really only has as a function to shade the viewers from the sun. So here you can see the 2 trusses are completely free span. They are buttressed here with concrete abutments to kind of hold them again in space to catch the tension. The parks fold up into the lobby, so the floor is moving up with the space. And the idea again is to work with a steel and glass facade, but with bamboo beams, as you can see here. So beams and columns are bamboo, steel and glass facade, and then the seating. So here you see how the building is essentially created between the seating and the facade and this huge wing. Beautiful was that when I asked them to make the wing essentially just with 2 trusses and nothing else, they told me that the compression ring had to be very, very strong. I'll show you in a minute. Here, so this compression ring really holds the whole thing in tension. And it is literally going from 1 meter diameter to 1.5 meters diameter. So 3 feet to 5 feet diameter of steel. And although that sounds a lot when we drew it parametrically in Rhino and in BIM, we realized the proportions were totally fine once this was 125 meters long. So here you see the lobby section, and then this is the wing as it sits. So here you see much more clearly how the field is really recessed in the park as a sculptural element, and how beautifully shaded the viewers are. The front, the park really moves up to the glass facade, this curved, basically single curve in this sense, with a cut to allow for the doors, and really big abutments. They're actually quite deep in the ground also to keep the 25-meter steel in place. And then the table tennis stadium is the main building really of the whole building. Here we were very interested in the idea of intersection. As I said, we were very we were really working between parametrics and local influences, and to see how we could tie back to local culture. So I was really fascinated by an object I found that had no real explanation for its existence, which is always interesting. It's called a Kong or a Chong. It's found in graves, especially around Hangzhou, and it's an intersection of a circle and a square. So that's where we started in the kind of looking for the hybrid form of the stadium. Again, we were not interested in the stadium as a single shape that is one function, but we were looking for the more complex intersection of spaces that could be used in multiple ways. We found very quickly that the square and circle were kind of limiting each other, so we went into more like two ellipses, as we called wobbly surfaces, that are kind of optimizing and rotating around each other. So this building is actually not centric, it's completely radial, both in layout. The center, nothing is in the center, everything is just constantly readjusting. And we have a suspend dome on the top. It's kind of a new form of large span roofs that essentially through high level of depth in the middle spans or pre-stresses itself, and hence supports itself completely column free. We asked the suspend dome to sit on the inner dome, so that the extension to the glass facade and the outside facade is completely free. So it's no weight on the facade whatsoever. And we started also to think of the seating as a hybrid between arena, sports arena seating, and theater and concert seating. So we studied the shape of an arena, looked at a theater, made a hybrid, and created a very I think very interesting way of seating that is much more fluid and soft, but it could potentially also have a pop concert in the middle. And then the building, as it starts to become, the building is, as the intersections in the facade, is like a tiling of, I'll show you in a second. It's a tiling of brass, as you can see here, and a steel and glass diagrid. For us, it was really important that the diagrid was a very large span, so it feels like a structural diagrid. But we also felt it was important to keep the glass planar and to have the idea of almost like fish scale skin that catches the light in completely different ways. So same facade consultant, Bill Logan, from Israel Berger, helped us out here. He made a set of very beautiful steel triangular fins that carry the glass and that allow for the glass to be really shard-like, which means that you get a stainless steel diagrid, then the triangular shards, and then the planar glass. Planar glass, of course, also reduces cost enormously. Again, the buildings had to be sustainable. So together with Thornton Tomasetti, we studied the passive strategies we could use and the active strategies. One was we used rainwater to be caught. We had openings at, just under the roof to evacuate hot air. It's very funny about ping pong is that you cannot have air conditioning because the ball is very light. So it cannot be disturbed. So the only thing we could air condition was the seats or under the seats of the viewers and the lobbies. So that's quite interesting. And then the top of the arena has indirect lighting. So we had as much as possible natural daylighting also. And here you start to see the building. So the intersection, as you can see here is really pushing through its own surfaces, but also creates this kind of idea of instability and constant adjustment that we like so much. And the diagrids are pushing through the brass shingle facades. Here you start to see the first BIM models of the interior. And then the stadium as we created this hybrid seating model and the indirect lighting. It's quite beautiful at night because you start to see the shapes intersecting really. The inner bowl is all bamboo. The outer, as I said, is this diagrid, and then the brass shingles. And then we get to the point of construction. So this project is extensive, and we really were saved by the fact that we have an extensive team that you see here. This is my business partner in New York, Justin Korhammer. This is the whole team in China that helps us is UAD at Zhejiang University in Hangzhou. And this is actually a group of clients and client engineers, and this is the client, where we are discussing how to create, for example, these structural innovations we were hoping to push through, and that they are doing pretty diligently, I have to say. And then one day after that meeting, we drove to the restaurant, and I'm looking sideways and I'm thinking, that looks really familiar. And I realized that our site already had a very pretty construction wall with all our renderings on it, which was a pretty strange moment to see that. And then a few months later, it goes in rapid speed here. We're on site looking at the construction. The site is so large that essentially we drive from building to building. And then here you start to see, the hybrid seating. Here is already poured in concrete. This is the inner dome, the river as it is existent. And then over here, they actually stopped the river from flowing on two sides in order to excavate for the valley here. So it's really interesting to see how they were doing this. Sorry, this is very unsharp. I didn't know that. Sorry. This is the Valley Village and the hockey stadium, and then this is more clear, the hockey stadium. So here you start to see that wall, the round wall going through the landscape. So the landscape goes up. This is a visitor center. I haven't talked much about, but it sits essentially under a green hill where you dip in here, and there is a glass cone in the middle where you can basically also enter. So this whole topology is slowly starting to happen, and they have poured for now all the seating. So this is also poured, and you start to see the walls going up. And then this is the whole project at night. It's a really extensive lighting scheme developed. What is really interesting is that they have, I asked them how they were going to do all these trees, and they told us that essentially they have a whole set of greeneries that have reserved enormous amounts of grown-up trees that last minute are going to be imported and put on all the topological surfaces that we have created. And then here on this corner, into the table tennis stadium, there's a walkable lake that has little tiny fountains. So it's very much for kids also to play in. But this is the river flowing through here. So the river actually does come through. And then this is a huge fitness center under this hill. Big parking garages on these sides. So flanked, this and this side are flanked of the Valley Village with parking, and also delivery areas and services like garbage removal and things like that. And then here you see the stadium. And then all that is going to be explained much more specifically about why we think strange objects are really important, new solids and massive forms. So yeah, again, for us, it's really in the prototyping phase that we feel we find these strange objects. It is the moment where we allow material discoveries to happen, but also formal explorations. We test a lot of different scenarios, and we we feel that in that phase is really where we conceive the project. So not so much in the computer in the beginning, although we're completely, of course, as everyone, parametric and digital. But for us, it's the combination of the digital and the material qualities that in a combination only give really what the actual effect or affect becomes for the project. And this is also where we feel that we find the identity or character of the project. So for us, this is why it's quite unusual, I think, for architects to work with manufacturers, but we work with manufacturers directly before we talk to contractors, because we feel that that's the only way to innovate fast in architecture. With contractors, especially in the US, that are slightly more conservative and like their traditional ways of doing things, it is much harder to innovate. So one of the things we've introduced on site is VIC. You might all know VIF is verify in field. We don't allow that. We ask for VIC, which is verify in the computer, which means that while concrete is being poured on site, we can have things already prefabricated, parts prefabricated in factories, so that we can really reduce the time and also the cost of the project. So thank you so much for joining me. It's really great to virtually be in Melbourne for a moment. I know your city very well, and I wish I was there.
Thank you. Thank you very much, Winka. That's fantastic. I mean, I'm really happy to be able to see these projects. I mean, some of these I know from previous lectures that you've given, as well as obviously looking them up online. But I was very interested to see the projects in Hangzhou, and one, see what stage they're at, but actually to understand the sort of genesis of them. And so I want to come back to that idea of genesis and obviously design development, design initiation and such. And you talked at the beginning about working through various generative processes. But then, and I think this was really interesting, the sort of focus on the role of prototyping. But in speaking about prototyping, you often also mentioned optimization. So I guess my question is partly when does prototyping want to take place? That is to say, you talk about it as being sort of in the middle. It's neither the beginning nor is it at the end. Mm-hmm. So the question is partly when is there enough of the beginning to begin prototyping, so to speak? Mm-hmm. But also, what underwrites the question of optimization? I mean, often the way it's used, certainly in sort of engineering circles, is either it's efficiency with materials, it's either reducing complex objects to simple objects, planar glass as opposed to double curved glass, and so on and so forth. So maybe you could speak just a little bit about how you situate prototyping. What's the earliest it can start, so to speak. Mm-hmm. And then also, what are the criteria, or what are the modes by which you optimize in a process?
Yeah, that's very good. So, it started very early on when I was working on the Yokohama competition. And we developed the process as a team, and we had figured that we wanted to simply take a surface that was vertical, make it horizontal, and flip it back to each other or to itself, and then do this twice and intersect them. And we literally were making this very quickly out of a cardboard strip and stitched it literally together. And we're looking at this thing thinking this is quite beautiful. The surprise came when we put it in the computer with Mathematica that it looked totally different. Because if you do this in Mathematica, it actually is the perfect version of something that is really made with cardboard that has a very low bending capacity. And the fact that we had the resistance of the cardboard to struggle with made actually for a much more beautiful proposals. So what we ended up doing was putting on the cardboard model every centimeter a dot and measuring it in. It was like scanning by hand. This is, you have to imagine, this is 95 or something. We basically measured every point and then put it in the computer as lines, then reconnected, meshed it, and then had the material resistance in the computer. And I think that is when I started to realize that whatever you design parametrically is much more interesting once you CNC it, and that you need to pay attention at that moment. And it's very, I always was a kind of a frustrated car designer. I think I really like the idea of industrial design and car design. I'm jealous of their precision, optimization, the fact that they can make prototypes, that cost millions of dollars. In our case, the building is the prototype often. But the fact that I realized how big the difference was in that Yokohama competition made for us very often asking for one-to-one sections to be looked at first before we finished the whole project. So that, for example, we did a store in Shanghai in the Bund where we recycled an old house and we CNC'd kind of a smooth surface out of it. And when we, by sheer coincidence, I guess, came to the factory where they were robotically CNCing this, we realized that the grooves of the CNC were much more beautiful than these people now spending 3 months sanding it. So that smooth is not always more interesting than the rugged or the unfinished or the rough. And in that case, what we did is we just rubbed it with silver powder and oil and just left the surface for whatever it was, which was a very clear, precise imprint from the computer, but not, it had the imprecision of the CNC router. And I think that has been our experience, that we really are on top of it in that phase, and that we find in those phases very often the things we feel are more interesting and more challenging and give more identity and character than the perfectly smooth or the incredibly refined or the, I'm not that interested in that. In that sense, what I said with Edmund Burke, his idea of the sublime and the idea of, and the horror is a big word, but like, the kind of unease or the almost ugly or the weird sense or uncanny idea of something that is too large for the space, that is kind of really squashed in the space. And as a person, you kind of have to really negotiate with this thing. I am more interested in those kind of moments that are not about beauty, but a strange ugliness that maybe make you fall in love with it more.
And relative to your office practice, then, is there a lot of quote unquote research into material practices? We have some of the same issues that you would have in the US, perhaps more because it's a smaller continent and stuff. But it's often very difficult to find out who are doing these new techniques, who's, using a new kind of way of fabricating a surface or putting two materials together. And so it seems that one of the things you're advocating is a really close understanding and awareness of new material practices, but that's often difficult because, as you said, they're often not happening in architecture. They might be happening in industrial design, or they might be happening in medical equipment, or they could be happening, in some other pharmaceutical pursuits or something. So how does your office deal with that, bringing in that external non-disciplinary knowledge into the practice?
Well, essentially, we take the risk. We are interested in this kind of research and innovation, and essentially you can't ask the client to pay for it. So I do this, or we do this ourselves in the office, where we have, it's also at some point you have several partners that have new materials, and they know that we are interested in it. And so often now people will come to us with like, we have a weird material, or we have a new way of manufacturing this, or so we tend to be partners in this, and we are pretty fearless in trying things out. So, this has been okay till now. We'll find out. But also I tend to not choose the most obvious choices. For example, the ring around the hockey roof, the 125-meter roof in one jump. They were like excluding the option of making this fat big ring, whereas I thought the fat big ring was actually the way to go. And that's also, I think, often the looking for the not obvious, or the other solution that gives it another way of experiencing it. And I think we all went through modernism, where it's plainer and light and glass. And I think I'm much more interested in the solid and the large and the clumsy, like to really test those kind of boundaries. I think is much more interesting than trying to make it light and fluffy. And I think by doing that, it does have a bigger probably chance of failure, or it's not commonly loved. But I think it's also, it gives an interesting, like people in 497 Greenwich with the folded glass, I realized people talk about that building that live in there. They talk about it like a pet. They don't talk about it as a building that they're just living in temporarily. And most people who moved in stayed, which is also interesting. So I think there is something about ownership, and people feel that sense of identity and character in something that they want to attach themselves to. And I think it's important. This kind of like sense of identity is something we lost very much. And I think it's interesting to find something that is grown outside of its own logic. It's not made according to commonly accepted formal languages.
So it's no longer, in that sense, it's no longer a kind of generic solution. It has a certain specificity that you can link to, because it's not just the same thing for the same people everywhere. It has a kind of specificity to it. We had last semester, the start of our semester, we had an exhibition which unfortunately got curtailed with the COVID restrictions, but it was called Future Prototyping. And one of our senior lecturers, Dr. Paul Lowe, has sent in a question. So Paul was the one who organized the exhibition on prototyping, so he's very interested. So his question, or his question is, thank you for a great lecture, Winka. For the Hangzhou project, can you elaborate on the practice's relationship to the local manufacturers? Is there any feedback as to the design process given the scale of the project and the speed of construction, which I think would be very different than the Inscape project, for instance,
Yeah, no, totally. We were lucky in the sense that it's very unusual, I think, in China that you do SD, DD, and construction details. And we are working directly with the BIM guys. So we have a slightly more extensive interest in the project, or like slight leverage in the project. I wouldn't say that I know exactly what's going on in every detail, but we do have a complete BIM model, and we can give feedback on details. And so a lot of the prototyping in this case we're doing through BIM. We asked them to do a lot of mock-ups, but the problem is right now we can't go there. So it's annoying, but they've been pretty good in sending us details and photos and drone fly-throughs that we have a reasonably good idea. It was great that we did go to site. We went to site 3 times already. So we did see it until recently, until basically March, when we couldn't go anymore, or February in that case. But we have been more than usual on site. And I think also because I was lucky that I was lecturing around the neighborhood, let's say, I also went out of my own initiative, which they thought was very strange. But yeah, so in a sense, they were good, and I think having a really good engineer in New York and also having a really good engineer there that got along, thank God, really helped. You know, because the engineering is really important, and then the detailing, I think. But to get the engineering right was really difficult with these large span structures.
Yeah, I think, I mean, that's a very interesting experience. I mean, the projects that we've done in China tend to be more, quote unquote, conventional office buildings, residential buildings, some retail and so forth. And we certainly, when we started working in China maybe 15 years ago or more, we found it quite complicated because, in fact, we would have some really good engineer support, but it would often be overlooked because we had to follow the Chinese regulations, which meant that an 800 square column actually had to become 1200 square, even though you could show that it wouldn't. So I think that, there's certain maybe specific about the projects in terms of big stadia that gives some leeway to the complications. Mm-hmm. But I think also the relationship to engineering has changed a lot in China, and the ability to work on these quite complex structures and to a certain degree take risks, not because it's a health and safety risk, but risk about what is the expectation of what the structure can do is really interesting. I have a question.
The suspend dome is actually currently being installed, and it's super scary how thin it is.
Yeah. I can imagine.
And you see these little people sitting on every knot, like every knot has a few little people on it. It's crazy looking. I should have put that photo in. Sorry, I forgot.
There's a question here from Scott Woods, who's on our faculty. He says, it's interesting to hear you say that a project's identity is found in the prototyping. Your idea of the kernel of a project seems similar in some ways to Alejandro Zarapolo's idea of the architectural project residing in or being about the detail. Are these two sides of the same coin, or do you see that as a different way, or is it part of where contemporary practice is headed?
No, I would think that we think slightly differently than Alejandro. I don't think it's necessarily in the detail. I feel it's more in the so I often start from a new kind of material or a new production method that I find, and I try and build that into the concept in a way that the concept and the method kind of maybe have some level of friction, so I can figure out which wins. So for me, it's much less about the perfect detail, but much more on kind of finding this friction or character or uncanny moment that is in the project rather than the perfect thing. I think Alejandro is much more looking for the perfect thing. I'm much more looking for maybe the imperfect thing, because I like to think that projects are more interesting when they have a level of, it's not so much imperfection, but there is a level of unfinishedness or being in still of becoming, or it's a kind of an unusual feeling or a spatial effect or whatever. So it's very much looking for something we haven't seen before either. So I wouldn't say that's why we start designing, but then because we always try and put in more information. So a lot of the time we use a technological innovation, but it's not about the technological innovation necessarily. It's more about the friction of the technology with the perfect thing we want. And then hopefully we find something that kind of generates itself, at some point. Yeah. So we're looking very much for a growth model rather than aesthetic formation or master plan. Mm-hmm. It's kind of hard to explain, but we let it grow at some point. So the beginning is very much like everyone else. We have a parametric model. We know it needs to have program. We need to have sizes and whatever. But then we just put uncomfortable things in it to try and see how we can get it to be different.
Mm. But I guess that for me, that comes back a little bit to this question of optimization. I mean, one of the questions somebody had is, what are the considerations given to cost? So, is optimization part of a kind of cost optimization? Mm-hmm. How can we make it cheaper to build. I mean,
Yeah.
or less expensive to build. But I guess it's interesting the example. I mean, you gave of importing, one of the, going back to the Cardiff Opera House, of importing this folded cardboard, because I would think that one of the consequences of a lot of optimization programs is actually to treat them to produce the kind of more perfect object. And so, is optimization, do you have to kind of also work against optimization, or is it actually how you structure what is being optimized? Because a lot of programs do want to produce the more kind of perfect object, as it were.
Yeah, well, the best example is the one you gave, like we realized that the budget was getting out of hand, and I honestly didn't want the curvature of the diagram to be round. Because the brass shingles are also overlapping and they're quite rugged, and I wanted them to age and to change. And the bellies, the wobbliness of the intersecting circles or ellipses also create this very unfinished, weird bulging through, the bulges of bulging coming through. So I felt that a perfect glass volume would be the opposite. So when we started looking at using planar glass, originally I was doing the perfect little mullions. Until I thought, wait, I have a facade engineer, let me ask him. And he said, no, you just need to leave it really big and just take the maximum size of glass that becomes your diagrid, and then just make it planar the way you want to do it, but just leave it large. And that was a huge breakthrough, but it also made it, again, less perfect and really weird, because now the glass reflections are all very different. So it's really like, I think the only way to do architecture in this way is to have some real geniuses on board, that have strange solutions to strange problems. And I think this guy, Bill Logan, who's a really good friend of mine by now, he's worked on all my projects also, but like, he's a sailor and he thinks differently about solutions than other people would, I think.
It seems
that helps.
Yeah, I mean, and in a sense, being able to, on the one hand, we see, certainly sort of architectural documentation is supposed to be complete and in a way foretelling everything. It's as if a way to check before it gets built, it's going to be correct. But there's always that surprise when it catches light in a way that you couldn't anticipate or you couldn't imagine. And it's in a way how to engender, you talked about it, at the beginning as being a kind of, there's a generative process to how you start a project and how you progress it, but there's also the generative or emergent quality of an effect that occurs that you can't necessarily always predict or plan ahead of time.
Yeah, you hope that what you create has a generative quality of itself, that it creates other circumstances, other environments than you had predicted or could even predict. But I think to come back to the person who asked the thing about the cost control, which I think is very interesting, because, we design things in schools that are ideal, right? And we are not hindered by costs, and so we can do whatever we want. And when I started my practice, as a young architect, I realized that was very frustrating, because you could not just make whatever you wanted. Not everyone gets this great project Don got in Melbourne. So the only way I found to go around that is to figure out how to innovate the project with manufacturers and control the cost, because I have already figured out who can do it. Maybe often more companies, like I find 2 or 3, and I do the pricing and I get it completely organized with these people before I go to the contractor. So I give the contractor a relatively simple, I call it anomalies, a simple 90% standard project with a 10% anomaly, or sometimes it's 50% anomaly. But all the parts that are anomalies, I have tried to figure out already and know the cost for. So it's taking a lot of liability, I guess, and it's also taking a lot of work on your shoulders. But I think it's fun, because to me, it's like battling the dragon. You try and get done what you want to get done, and you just figure out a way around it. Yeah. And so I don't mind that, but it's not for everyone. Not everyone wants to do all that extra work, but I love that part of it. I really think that's I see it as a game, and I think it's hilarious to get it done. It's really important, and why would you want to fail?
Yeah.
So.
Great. There's a question here going back to some of the projects in New York dealing with questions around sustainability. And one of the questions is that with the projects in New York, the concern over the fact that some of the materials are quarried in Italy, or they're quarried in Portugal, the glass is coming from Europe in some way and having to be brought to New York and stuff. What are the net impacts from an environmental point of view of projects like that?
Yeah, that's a very good question. We haven't been able to completely figure that out because there's a lot of stuff we can't get in the US. It's really hard to do that. But what we did figure out is, for example, when we got the stone from Portugal, it went to Italy. That was easy, actually. That just went on a boat. And then from Italy, it just basically, that company has a company in the US, so it went with a lot of other stuff. It didn't have to have its own transport. It just came with other building materials for similar buildings in a similar area. So not perfect, but there is that problem that we cannot, even if we find, for example, we used for vestry very beautiful Schuko mullions that are ultra thin and really beautiful titanium finish. I cannot get those here. I need to buy those in Germany, because here I only get the very dumb ones, the big, fat, aluminum, ugly, standard, aluminum finish and natural anodized that no one wants to use mullions. And so it's been a handicap being here, and that's why I focus very much on prefabrication and trying to optimize it that way, and like Inkscape to make manuals and shipping packing diagrams for intermodal shipping. So it's trying to solve it, but it's not perfect. I totally agree. So it's a toss-up. Do you want ugly mullions or do you want the perfect mullion? You find someone who has a company there and here. So that's what I usually try. I would be happier. I tried to convince Schuko to make those mullions here, but they laughed at me. So, didn't work.
I mean, you've shown
us, it's a big market. I was come on,
They should, for sure.
Yeah.
You've shown us projects that have more or less already taken place, and the ones in Hangzhou they're under construction. But what about other projects that are currently on the board or that you're working on, and particularly like some of the high-rise projects? And in that, then again, this question of the balance between value management optimization and the material design, does that change depending on the type of project? That if it's a commercial high-rise office residential, you put one kind of emphasis. If it's a more unique project like a stadium or a big master plan, then it's a different kind of focus.
I always work with a kind of 10 to 20% anomaly idea. I think normally I can't find clients that will pay for my 200% anomaly building. So I try and make it, for example, a tower, I'll try and do a normal curtain wall, but I'll insert like an anomaly that makes it into something else, like the Black Tower in Rotterdam. To me, it's also more interesting to see whether you can get away with a pretty standard system and then see the anomalies as special moments within a standard. So to kind of get the non-standard and the standard together. I'm more interested in the anomaly than the full-on blown anomaly completely. So I'm not that interested in something that is completely crazy. I like something that is pretty much more standard. I feel that for example, with skyscrapers, that the beauty of skyscrapers is a lot of skyscrapers together rather than one incredibly special tower. I'm not that interested in that. I'm more interested in the kind of pollution of the simple tower than the whole tower to be that particular. So I am not, I don't like, again, like, you know, I don't like the total smooth surface. So for me, it's more interesting to insert things and to see whether I can create character and identity that way.
Mm-hmm.
But yeah, I would like to, you know, I rather do a normal tower with some anomaly.
It's I mean, it's been great being able to see the projects both completed and those that are under construction. But one of the reasons which I really wanted to see and hear you talk about, but also one of the reasons I wanted to invite you for this is also because your role at University of Pennsylvania and as chair of architecture there. So I wonder if you could talk just for a few minutes about, you know, what are those linkages both between how you practice, but also how you've set up the program at Pennsylvania and how you've changed it. You said you've been there for about 8 years now or something. So obviously it's sort of matured under your guidance. What are your, you know, what are your interests or what are your focus for the program at Penn?
Mm-hmm. Well, you know, you learn from other places, right? So I taught at Harvard, and Harvard was a really amazing host and really professional. And I thought I was very impressed with that when I was teaching there. MIT Media Lab, I always loved the fact that inventions were the rule and that external experts were, or external money or external companies were providing the kind of spine for it. So when I became chair at Penn, the most important thing I thought was for us is to really see, like, what is it that we want students to know when they leave Penn? It's really about students ultimately, as we know, you know, we are doing everything for you guys. So what I felt is that it's really important to understand experts and knowing that you are always running a team of experts and that your biggest winning moment will be if you get the best experts together that will all work with you on something, because nothing in architecture is going to ever happen by you alone. And I don't believe in the big ego as architect. I really believe in teams and getting the best geniuses together. So when I started Penn, I wanted to be a better host like Harvard. And so I started giving an annual symposium, we created an annual book that we give away. We invite a lot of people to come and lecture. We try and be really good hosts to them. But this is also about exchange of knowledge, peer-to-peer communication, understanding that it's important to get people to talk to you and to talk to them, right? So that was one thing. The other thing I did was I made a lot of connections to companies that sponsor us, like concrete companies, carbon fiber companies, whatever. And they sponsor research. They ask us to do research with them. So our students get to be part of like really interesting research, really important, far advanced knowledge bases that are much more than what you could ever do in the school. So I'm trying to, especially in the last year, to expand the knowledge of the students in a really drastic way. So it's much more like the MIT Media Lab, whereas in the first 2 years, I have accreditation to take care of. So we do really good, solid knowledge building, but also there we integrate a lot of technical knowledge in the design studio, a lot of theoretical knowledge in the design studio. So it's not just, you know, here are your courses and you do the studio, but we integrate, we try and teach very integrated. So that you know how to use, we have studios where actual engineers from over Europe and Bureau Happold and whatever come and work with our students. So they come once a month, you get your own engineer and you get to work with an engineer on your project. But that comes with restrictions and negotiations and compromises and really interesting discussions. So I think those kind of things really change the school. Apart from that, I think every student needs to know all the software. You need to work cross-platform. You need to understand boring things like BIM and really great things like Maya and Rhino and all the plugins. And there is no way around it because no one really draws on a table anymore. So, you know, I think this phase where we're all working online is quite interesting because a lot of us architects work like Zoom. You know, we have meetings on Zoom forever with people in China and Europe. So in a way, it's a really good phase for students to learn how to work in the future because it will be a lot like this. And you have to convince an engineer that sits on the other side of the screen and you're not on the other side of the table. And you have to convince him to do what you want to do, you know, like, and you need to negotiate the terms. And so negotiation will be a big part of, you know, and convincing and inspiring people is a big part of what you do as an architect. Mm. So I basically try and make this school as I think we need to be in the next 25 years as architects. So that's kind of what I base it on. And then I add, for me, my own little dreams of like, you know, that I really would like to be the MIT Media Lab of architecture and that I like to be a really good host.
Great.
So yeah, we invite people like you.
Yeah. No, I'm waiting for the planes to be back in the air so we can come over and see the work that's going on there. Listen, Winka, we're going to wrap it up here. We really want to thank you for your generous time and for your presentation. It's been fantastic to not just see the projects, but actually understand better how they're generated, how they're developed, how they're realized, and to look forward to the completion, particularly in Hangzhou, of the stadiums for the Asian 2022 games that we're looking forward to. So again, thank you very much for being a part of this. Thank you for joining us. I know it's almost midnight over there, so we'll let you go to your deer and squirrels in your backyard that you have. And before I wrap up, I just wanted to make a few announcements. So we have another one of the MSD at home this evening. This is MSD at home with Djordje STOJANOVIC, who will be speaking about our common future question, the reemergence of collaborative housing in the 21st century. This will happen today at 17:30, 5:30 Melbourne time for about an hour and a half, and that's being directed by Djordje STOJANOVIC. And then on Friday, we have the future of residential property market. This is a kind of roundtable discussion. This will happen on Friday at noon, from noon till 1 o'clock. In conversation with Professor Payush Teshwari, people from the REA group, from Lend-Lease, and from Urbis speaking. And then next week, we have our very first lecture in an extension to the series MSD at Home. This is MSD at Home, Melbourne Speaks. And this is a series which will bring our senior academics from within the faculty every Tuesday, or almost every Tuesday, speaking about their work, the themes that they're developing, what they're interested in. So next Tuesday, the 1st of September at 6 p.m., please join us for the inaugural presentation by Professor Hélène Frichot, who's Professor of Architecture and Philosophy within the faculty and the head of the Bachelor of Design degree program that we have. There'll be more projects coming after that in terms of MSD at home, so please join in. This presentation by Winka Dubbeldam has been recorded and will be uploaded once we've edited it down and everything. But just a final thank you again to Winka for joining us, for participating and being so generous with her time. Thank you very much, Winka, and we'll speak to you soon. Bye-bye.
Bye.
Goodbye, everyone.